A cardboard box without a lid must have a volume of 23,328 centimeter cube. So we got volume, fixed volume. Find the dimensions that minimize the amount of cardboard used. So here is a cardboard box. There is no top, so only 5 sides. Okay, the material is used on 5 sides: bottom, left, right, front, back. So the volume is given. So let's say the dimensions are x, length, width y, and height g. So volume V, which is x times y times z, is equal to 23,328. So x, y, z equals this. So let's solve this in terms of g. So g equals 23,328 over xy. Okay, so this is our surface kind of equation. Next, what we're gonna do here is that minimize the amount of cardboard used. The cardboard is used on the surfaces. So surface area is, the bottom part is just x times y. There is no lids, just xy, plus front, that's the x times z, and back same thing, so 2xz, plus right side, let's see, y times z, and left y times z, so 2yz. So we want to minimize this function, in fact. So let's replace g from here. So then we get xy plus 2 times x times z. G is 23,328 over xy. Then x and x cancel, so this is 46,656 over, since we have x, cancel y, plus, similarly g is this, so 2 times 23,328 is 46,656 over y, cancel the x on the bottom. Okay, now this is our surface area function. Now we want to minimize this. In any case, we need to take partial derivative with respect to x and with respect to y, because this is a function of 2 variables. So partial with respect to x is, with respect to x, 1y, with respect to x, this is 0 because there is no x. With respect to x, we have constant survives 1 over x, and we know that derivative of 1 over x is negative 1 over x squared. So this will be the constant 46,656 over x squared. And partial of this with respect to y, with respect to y, x survives x. Here same thing, minus, it's like 1 over y, so same thing, 46,656 over y squared, and this is 0 because there is no y. Okay, let me erase this. Now we set the partial derivatives equal to 0 to find the critical points. So let's set x as x0. That means this equals 0. So y is equal to 46,656 over x squared. So we are basically trying to find the critical points. So we set sx0 and sy0 and find the values of x and y. So setting the first partial 0 means we got y in terms of x, and set y0, that means this equals 0, x minus 46,656 over y square equals 0. I did not solve for x because I said this equals 0 and isolated y. Now I'm gonna plug this y into this fraction so that we can find the x value. So this implies x minus 46,656 over y squared. That means this fraction is squared. 46,656 over x square equals 0. So let's simplify this. Or we have x minus x square export, that goes on the top, and we have same thing but 2 copies on the bottom, so 1 copy is cancelled, so 46 656 left on the bottom equals 0. Let's solve this equation, or from these two terms we can factor x out because x and export. So 1 minus, out of 4 copies, 3 left on the top, and just the number, that constant, 46 656 equals 0. This implies either x 0, but that's not the case. If x length is 0 and there is no cardboard box, so x not 0 means this equals 0, and we can find the value of x. 1 minus x cubed over 46 656 equals 0. Move this over, or multiply both sides by this bottom, we get x cubed equals 46 656. Take cube root both sides, then you get x equals 36. Okay, so x is 36. If we plug this x here, we get y. Okay, and if we plug x and y on the top here, we get z, and that's how we find the critical point. Okay, x is 36, then y will be just from here, divide by 36 squared, then it will be 36 again, you can check. And g is, if you go top here, plug in x and y and divide 328 by x times y, you get 18. So we have only one critical point. That means this should be the answer. So these dimensions minimize the amount of cardboard used. Thus the dimensions 36 centimeter by 36 centimeter by 18 centimeter. Final.